Electronegativity. Electronegativity is the property of an atom which increases with its tendency to attract the electrons of a bond. If two bonded atoms have the same electronegativity values as each other, they share electrons equally in a covalent bond. Usually, the electrons in a chemical bond are more attracted to one atom, the more electronegative one, than to the other. This results in a polar covalent bond. If the electronegativity values are very different, the electrons aren't shared at all. One atom essentially takes the bond electrons from the other atom, forming an ionic bond. In 1932, Linus Pauling proposed an electronegativity scale based on bond energies. Electronegativity values on the Pauling scale are dimensionless numbers that run from about 0.7 to 3.98. Electronegativity is a property of an atom within a molecule, rather than an inherent property of an atom by itself. Thus, electronegativity actually varies depending on an atom's environment. However, most of the time an atom displays similar behavior in different situations. Factors that affect electronegativity include the nuclear charge and the number and location of electrons in an atom. Electronegativity has a periodic table trend. Like electron affinity, atomic radius, ionic radius, and ionization energy, electronegativity shows a definite trend on the periodic table. Electronegativity generally increases moving from left to right across a period. The noble gases tend to be exceptions to this trend. Electronegativity generally decreases moving down a periodic table group. This correlates with the increased distance between the nucleus and the valence electrons. Electronegativity and ionization energy follow the same periodic table trend. Elements that have low ionization energies tend to have low electronegativities. The nuclei of these atoms don't exert a strong pull on electrons. Similarly, elements that have high ionization energies tend to have high electronegativity values. The atomic nucleus exerts a strong pull on electrons.